Welcome students to Lesson 51. This is Algebra 2. We are going to talk a little bit about imaginary numbers and square roots. So we know that positive 2 and negative 2 are both square roots of 4 because we can say positive 2 squared equals 4, and we can say that negative 2 squared equals 4. And we remember that when we use the notation the square root of 4, we are designating that as positive 2. We reserve that notation to designate the principal or the positive square root. If we want to designate negative 2 as the answer, we say negative square root of 4 equals negative 2. If we want to designate that either one of those is a possibility, we say plus or minus the square root of 4, which gives us positive 2 or negative 2 as a result. So we have specific designations, right? If we just want the positive number, we don't do anything special. If we want the negative number, we put the negative on the outside. And if we want both, we put positive and negative on the outside to give us both. And we understand that. That makes sense, right? You can see that, and we know that that makes sense. So what if we are given something that looks like this, where you have the negative on the inside? How in the world do we deal with that? We can't do negative 2 because a negative times a negative is a positive. So this should be positive, but it's not. It's a negative. Well, this guy, a long time ago, he was a brilliant mathematician. He came up with the idea of imaginary numbers. And he determined that the square root of negative 1 is an imaginary number. It can't happen. It doesn't, it could happen, like when we're given this problem here, but there's no solution for it. There's no way you can say a negative times a negative and get a negative. It just doesn't work with all of our other math rules. So he created a notation called Euler's. It's the reason I get confused is because his name is spelled like that, but you pronounce it like that. Euler's notation. And it is the imaginary number of square root of negative 1. And his notation is the lowercase letter I. And that is one of the reasons why you have never seen a lowercase I as a variable, because it always stands for the square root of negative 1. We can't find that on the number line. Nowhere on the number line, if you look at it, we could find the square root of a 4, which is 2. And we could find the negative square root of 4, which is negative 2, right? We can find those. We have positive numbers, and we have negative numbers. And we could find negative 2, and we could find positive 2 all day long, no problem. But a negative times a negative that gives you a negative, that doesn't happen. So he created a notation to pull this negative 1 that is being squared, or you're trying to find the square of, out, so that you could complete a calculation on the rest of the problem and just make this little note to the side. It's a simplification method so that we can go ahead and solve the rest of it. So what that does, it allows us to say the square root of 4i, which means we can then further solve it as 2 with a variable of I. So we know what this is. We know that this is the square root of negative 1. That also means that if we have 2 i's, the square root of negative 1 times the square root of negative 1 that must mean we have 2 times the negative 1. Because we know if we have the square root of 2 times the square root of 2, it just equals 2. The same thing is true for this. The square root of negative 1 times the square root of negative 1 is negative 1. So when we have I and I times each other, we get negative 1. And that is what Euler called this, an imaginary number, because you cannot solve this into a real number and put it on the number line. And the number line contains only real numbers. They could be non-terminating repeating decimals, irrational, but they're still on the number line because they're 3 point something, 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 or 15 point something, 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 something. They're still on there. They have a designated place, but we can't designate a place for this. So that is why he used the letter I for imaginary. That being said, let's look at some practice problems. We have, first of all, 51.1. We have in A, we are given, and this is a problem, square root of 3 times the square root of 2. In B, we have the square root of 3 times the square root of negative 2. And in C, we have the square root of negative 3 times the square root of negative 2. Now, normally, this is what we would do. We would say, oh, this is the square root of 6. This would be the square root of negative 6. And then we would say, okay, this factors out to negative 1 times 3 times negative 1 times 2. So negative 1 times negative 1, those square roots would be a negative on the outside. That'd be negative 1 times the square root of 6. All right, because we factored out the negative ones. And if you have a negative times a negative, you can do that. You can pull out and pull the negative 1 to the outside. That's the same thing that happens when we have the two variable i's, negative 1. Square root of negative 1 times the square root of negative 1 is negative 1. All right, let's do 51.2. Let's see if we can do this one on our own. So I'm going to give you, in this one we have A, which is the square root of negative 13, and B, which is the square root of negative 4, and C, which is 3 times the square root of negative 2. And I want you to use, I keep saying Euler. It's Euler. His name is Euler. It's just spelled Euler. Euler's notation to solve these three. Should only take you a minute or two. I want you to pause the video, do those, and come right back. Okay? All right, here's what you should have gotten. You should have taken the negative 1 out and turned it into an I. So the square root of 13 times I. Here, we took the negative 1 out and turned it into the I. And then we unsquared the 4 to 2. And that would have been 2I. Now for this one, we took the I out of the here. We factored it. And we had basically this right here. We had negative 1, square root of negative 1 times the square root of 2. We multiplied the square root of 3 times the square root of 2. And then we have the I next to it. So the square root of 6 times I would be the answer for C. All right, let's jump into a math problem using imaginary numbers. Let me clear the page for us. And we're going to do 51.3. And this says 4 plus 6I plus 3I minus 2. All right, I want you to solve that one. It's just like you normally would with a variable. You look for like terms and solve it. So pause, solve it, and come right back. All right, you should have gotten 2 plus 9i. So we had a positive 6i and a positive 3i. You treat it just like a variable. They're like terms. You add them together and you get a positive 9i. And then you had 4 minus 2 is 2. Easy peasy. You guys can do this. It is what you think it is for most of the time. Okay? So let's do one that's just a little bit more. Just a little bit more, not a lot more. I want you to solve this one as well because this is not super difficult. We just have parentheses added in. Here we go. Minus 2 minus 5i. That's a 5. All right, pause and solve that one for me. All right, that one should have been easy peasy as well. The only thing that you had to remember was when you got to this minus right here, that you put your -1 in front, and you say -1 times 2, which is -2, and -1 times -5i, which would have made that a positive 5i. So then you have positive 4, positive 6 is 10, minus 2 is 8. -3, -4 is -7, plus 5 is -2i. And that would have been the answer for 51.4. Easy peasy. Oh my goodness. It is what you think it is. I promise. All right, so let's do one that is just a little bit more difficult. I'm just going to stretch your brain just a tiny, tiny bit. And we're going to apply some logic and think about this problem right here. We have 2 i's here. We have 3 i's here. And yes, I just cursived them all together. Plus 2i minus 4 minus square root of -4. All right, so let's logic through this. We know that I is the square root of -1. So it stands to reason, as we talked about before, that if we have 2 i's, then we have the square root of -1 times the square root of -1, which should equal the square root of -1, and it does. So if you have 2 i's, you can pair them and turn it into a -1. So we have 3 i's here, so that means we've got a -1. We can get rid of 2 of them and have 1 left, right? Plus 2i minus 4 minus, and we have the square root of -4, which would be the square root of 4 times the square root of -1. The square root of 4 is 2, and then we have the square root of -1, which is I. All right, if we look at this, we have a positive 2i and a negative 2i. They just canceled each other out. Gone. 2 times -1 is a -2. Then we have -3 times a -1. So we have positive 3, and we still have that I. And a minus 4. That's all that's left. -2, -4. That's going to be 3i minus 6. And that is the answer. How neat is that? It's nice to actually have a variable that you know the value is and you don't have to find it. You can just go ahead and sub it in, even if it is a little bit difficult. So what matters based on this problem is, do I have an even number of i's? Because if you have an even number, then you can pair them up into -1s and get rid of them. That means if you have 4 i's, then it's the same as having anything to the 0. It would just equal 1. So if we have I times I, or that would be I squared, that would equal -1. But if we have I times I times I times I, that would equal I to the fourth, that would equal a positive 1, because that would be negative 1 times negative 1, which would be positive 1. How about that? And that leads us, you might want to put that in your notes. That would be important to remember. That leads us into 51.6. So in 51.6, we have 3, and now we're going to start using some exponents on here. 3i cubed plus 2i squared. Isn't that what we had up here? 2i squared, 3i cubed. It sure is. And plus 7i. So 7i to the 1. Plus 4. Plus 2i to the 5th. All right. So in looking at this, I see automatically that 2i squared, that's going to be negative 1. So 2 times negative 1, that's going to become a negative 2. Okay? And I have 3i cubed. So if I take I squared out of here and multiply it times 3, that becomes negative 3i. 7i, I can't do anything with it. It still stays there. Plus 4. And then I have I to the 5th. Well, if I take I to the 4th out of that and turn it into 1, I still have 1i remaining. So 1 times 2, that's going to be 2i is what I have left. All right, so now I have some terms that I can do something with. I have 3 like terms with i's. So negative 3 and a positive 7 is a positive 4 plus 2. That should give us plus 6i. And I have a negative 2 and a positive 4. That should give us a positive 2. So 2 plus 6i is the answer to 51.6. All right, and that is all we have for lesson 51. I will see you in lesson 52.